Hi everyone, in today's lesson I will talk about how to determine number of intersections between a straight line and a quadratic curve. So please turn to a new page of your notebook, write down the dates of today and the learning targets. So first we can consider a set of simultaneous equations containing a quadratic equation and a equation of straight line. So for the quadratic equation, we have y equals to a1x squared plus b1x plus c1. And this is our first equation. So for the equation of straight line, we have y equals to mx plus c2. And this is our second equation. So my question is, when I combine these two equations together, so what do you expect? What is the result do you expect? Okay, so let's do it together. So we can substitute the second equation into the first one. And we have mx plus c2 equals to a1x squared plus b1x plus c1. Okay, then we can make one sign to be 0 to form a quadratic equation. Then we can simplify it by grouping the like terms. So for plus b1x, we can combine with minus mx. And then for plus c1, we can combine with minus c2. And we have a1 x squared plus b1 minus m x plus c1 minus c2. Okay, and finally we can get the final answer by rewriting it. a1 x squared plus b1 minus m x plus c1 minus c2 equal to 0. And this is a quadratic equation. Okay, so now for this quadratic equation, there are two ways. The first way, we can solve it. Okay, if we know all the numbers. Okay, so by solving it, we know the intersections between these two equations. Okay, also we can use delta b squared minus 4ac to determine the number of intersections. So when we consider delta, there are three cases. Graphically, the three cases look like this. The first one will be like this, and the second one will be like this, and the third one will be like this. Okay, visually we can see that in the first case there are two intersections, in the second case there is one intersection, and for the third case there is no intersection. Okay, so we can write it down. Two intersections. One intersection. And no intersections. And then, in terms of solutions, we know that if there are two intersections, that means we have two real solutions. And for one intersection, that means there is one real solution. And for the third case, that means there are no real solutions. Okay, and finally, in terms of delta, If there are two intersections, that means delta is greater than 0. And if there is one intersection, that means delta is equals to 0. And for the third one, that means delta is smaller than 0. Okay, so we can make the conclusion. So if we combine these simultaneous equations, so we can form a quadratic equations. Okay, so for the first way, we can solve the quadratic equation, okay, to find the coordinates of intersections between the quadratic equation and the equation of straight line. Okay, also we can use delta, okay, to determine the number of intersections. So if delta is greater than 0, that means there are two intersections and two real solutions. Okay, if delta is equals to 0, that means there is only one intersection or one real solution. And finally, if delta is smaller than 0, that means there are no intersections or no real solutions. So now, please help me to finish the following classwork, and then I will check the answer with you later. So let's check the answers for yourself.